Welcome to Learning Java. I am Dr. Pierce, and today we will discuss comparing floating point numbers. As you know, we can use conditional statements to compare two integers to each other, and Java does this quite nicely. We can say if count is equal to 5, and as long as count is an integer, this comparison can be done quite easily. This is because integers have precise values. However, what if the values you are comparing are not just integers, but floating point numbers instead? So is 0.00014 the same as 0.00014,235? Well, at first glance, you might say, well, no, they are not the same. But what if, when we compare them, they are the same value, but one was we dropped some precision on it. So this is the problem with floating point comparisons. With floating point representation, minor rounding differences can occur in calculations. Okay, so let's look at a couple examples here. So what if we multiplied 11 times 0.1? And then we also added 0.1 11 times. Mathematically, they should be the same. If you take 5 times 4, you're going to get 20. If you take 5 plus 5 plus 5 plus 5, you're going to get 20. And if you do the math on a calculator, you're going to see that you get the exact same answer. Mathematically, they are exactly the same. But wait, let's look at the code for each of them. So here is, we've taken the 0.1 as value, the 11 as a multiplier, we multiply them together, we get multiply, and now let's output. Okay. We can see that when we output it, we get 1.1, okay, which is what we would expect. Okay, so now what if we did addition? We wanted to add the 0.1, we want to add it 11 times. So we're going to set a variable adder equal to 0. We're going to go from 1 to the multiplier, which is 11. So we're going to do this 11 times, and we're going to add 0.1. We're going to add 0.1 to adder, and we're going to do this 11 times. Now and we see that we don't exactly get the same answer. So the result in this time is 1.09999. If we compare these two values using the equality equals operator, they would not compare as equal. We would get similar results when assigning the same value to a float variable and to a double variable, and then comparing the results. Okay, clear. Here we clearly see two values that are clearly set to be the same. So let's take a look at what that looks like. Okay, so here we've defined the variables. Let's just go ahead and output them. We can confirm that they are the same value. Okay, so let's do it. So what would happen if we did a comparison then? Let's do the simple equality comparison. So we're just going to compare value 1 to value 2 because we've already confirmed that they are the same value. So what happens if we do a comparison? Let's run it. Okay. It says they are not equal, but wait, they are equal. This is due to the way Java handles floating point numbers. The actual numbers stored are unpredictable. We don't need to understand here what happens behind the scenes with floating point numbers. But we do need to understand that we can never do a simple comparison of two doubles, as the results are unpredictable. Instead, we need to determine if two floating point numbers are close enough to be considered equal. To do this, we need to determine the threshold value. In other words, how close do the numbers need to be to each other to be considered equal? Take the absolute value of the difference between the two values. So in other words, subtract the two values, take the absolute value of it, and then compare the two. So let's take a look at this in Java code. We found a threshold. So we're saying as long as they two are within 0.0001 of each other, that we are going to consider them equal. Okay. So now we're going to take the difference, the absolute value of the difference. So the math absolute value, and then the difference. Okay. And then if the difference of the absolute value is less than this threshold value, then we're going to say they're equal. Otherwise, we're going to say they're not equal. Now, based on our previous assessment, they said that they were not equal. So let's see what happens now when we consider a threshold value. Now we see that the two numbers are equal, but as we add zeros to it, so eventually we're going to reach the point where our threshold value no longer makes them equal. Never do a direct comparison of two floating point numbers. Instead, we need to determine the threshold of accuracy we are looking for. Take the difference of the absolute values and compare them to the threshold value. Thanks for watching.